I'm Paul, and I'm going to talk to you today about the upcoming solar eclipse on the 12th of August 2026, i.e. in a few weeks' time. And I'm going to just explain how it happens, first of all. Really, what happens is that by a strange coincidence, the sun and the moon appear approximately the same size in the sky. And the moon orbits the Earth once a month, or once actually every 27 or 29 days, depending on how you define it. But it was just convenient to have 12 months in a year, so they made the months a bit longer. And also, the moon and the Earth together, they rotate around the sun once a year, which is 365 and a quarter days. Unfortunately, the moon orbits the Earth at an angle of 5 degrees, because otherwise we'd have total solar eclipses every month, which would be really nice, but it doesn't work like that, I'm afraid. So what we get instead is every now and then the two orbits coincide and the sun and the moon meet in the sky at the time of the new moon, and from certain parts of the Earth only, the moon will move directly in front of the sun, covering it up completely, because they appear the same size. So the way that the eclipse works is that the moon comes between the sun and the Earth, and the moon casts a shadow onto a narrow corridor of the Earth, only about 100 miles or so wide. It depends on a few bits of geometry, how wide it actually is. If you're actually right under that shadow, you will see a total solar eclipse, which is the best sort to see. Now, we in Armagh are quite off the centre line of this one coming up, so we'll see a very deep partial eclipse, which is good, but not quite as good as seeing the totality, which, just to get a little bit technical, the moon's rotation around the Earth can be measured about 3 different ways. 29 and a half days is from full moon to full moon. 27.21 days is from the same node, i.e. the point where the orbits cross. And 27.55 days is the time to return to its closest point, the perigee. And when you put those 3 numbers together, you'll find that they recur every 18 years, 11 days, depending on leap years, and 8 hours. And the 8 hours in this is very, very important. So the upshot of this is that the same eclipse will come round every 18 years, 11 days, and 8 hours. But because of the 8 hours, it will be displaced on the Earth by 120 degrees. But after 54 years, it will come round again. So see the diagram there where we have the eclipses in 1988, 2006, which I was at in Turkey, 2024, which I was at that same eclipse in Niagara Falls in Canada, and it's the same one that's mentioned in Carly Simon's song, the 1970 version of that. So you flew your Learjet up to Nova Scotia to see the total eclipse of the sun. That's, of course, You're So Vain. Just to give you a heads up on some upcoming total solar eclipses, the next one in the UK and Ireland, and it's just in Ireland, off the bottom of just below Cork, and so 23rd of September 2090. So a bit of a while to wait there, but there is one in northern Spain. That is the same one that is visible here in Armagh as a deep partial. That is total from the north of Spain down through the middle of Spain and into the Balearic Islands in the Mediterranean. That is the one on the 12th of August 2026. Then there's another one in southern Spain, actually, next year, 2027, 2nd of August. And that one goes through Gibraltar, bottom of Spain, north of Africa, right the way along the Mediterranean into Egypt and further down. And it is actually the longest remaining totality of this century. There's an annular eclipse, which is where the moon's shadow doesn't quite reach the Earth, and there's a ring of sun around it. And that's also visible in Portugal and Spain on the 26th of January 2028. And then a particularly spectacular eclipse passes right through the middle of Sydney, Australia, on July the 22nd, 2028. And there's one more in southern Africa and Australia on the 25th of November 2030. Now we're looking here at the path of the eclipse that we'll be seeing in August, weather permitting, of course. And you'll note now the dark band down the middle, that is the zone of totality. So if you get inside that area, you will see a total solar eclipse. But we in Armagh were a bit out of it, and we see 94% of totality, which is interesting. It's not as good as seeing the totality, but you see where you have to be to see the totality. Starting at the top of the graphic, you see that the east part of Greenland gets a look in, then a little bit of the western side of Iceland, then it comes right down through the Atlantic to northern Spain, goes across the middle of Spain, and then comes down off the east coast of Spain into the Mediterranean at the Balearic Islands, Mallorca, Minorca and Ibiza. All of those islands will get to see it. However, by that time, you're seeing the eclipse at sunset and quite possibly through a lot of cloud. Now let's just have a look at that eclipse as we're going to see it from Armagh. It will come in about 1811 or so, and then you'll see a dent appear in the side of the sun, which will travel across the sun at much slower speed than that, takes about an hour. Then you'll still see that irritating little sliver of sun that won't go away, this time at the top. The moon moves out of the path of vision and ends. Now, when it comes to viewing the eclipse, we are dealing with sunlight here, and safety is absolutely paramount. You only have one pair of eyes, and you need to look after them. So never ever look at the sun directly, even during the eclipse. There is one tiny exception to that, is that if you're in a total eclipse, you can look at the sun to see the atmosphere of the sun, the corona, during the totality. But this eclipse in Armagh and Northern Ireland is not total at all, so there is no time that you can look directly at the sun. Now, one way of doing that is eclipse glasses, and these are available. Probably will be quite available in shops and so on there. The astronomy clubs have got them. I think the planetarium's got them. And all you need to just check there is that they've got a CE marking on them and that they do actually look dark. Hold them up to the light first, just to check that there's no light coming through them, and then they'll probably be safe to use. So do that. Now, but absolutely do not use those glasses to look through binoculars or a telescope, because what happens there is that the optics of the telescope will actually gather enough light to burn a hole right through the glasses and then straight into your eye and burn your eyesight out. So don't be doing that. Another very safe method of doing this is projection. And you can see here I've built a setup there using a small telescope. That's one of the 70mm refractors that the German supermarket sells from time to time. And I've kept it all low to the ground so that no one can accidentally look through the eyepiece. I've put a 10mm eyepiece on the scope, so that gives a good magnification. Then I've built a screen on a box using an A4 sheet of paper, actually an A3 sheet of paper there, and projected the sun onto that screen, and it comes out very well, as you see at the bottom picture there. Again, just do not look through the telescope at any time there, because that is unfiltered sunlight. Now, it is possible to make a filter for your telescope using a material called Barder film, and there's some pictures of me doing that some while ago there, using tape and cardboard and Barder film. I would advise that you don't do this unless you've done it before or are with someone who's done it before. But you can make a very effective filter there. The material, though, is quite expensive, as you'll see in the graphic I've included there. It's you get an A4 sheet for about £30 these days. And there's one I made earlier in Blue Peter style, and I made a mistake. On my refractor telescope there, I've got a perfectly good filter on the front, and it works. But I forgot about the finder scope, and I have actually witnessed someone who should have known better neatly roasting their hair with the finder scope while they were looking through a telescope, which was otherwise fine. A perhaps more modern way of watching the eclipse safely is to use a smart telescope, and I'm showing a picture here of my C-Star S50 with its nice included solar filter, which does a very good job of filtering the sun. You see actually a picture that I took with it of the sun with sunspots on it last year, but not obviously during any eclipse or so. Very good way of doing it, very safe. It will find your subject for you and will track it and will film it for you. Here's a few pictures I took at the total solar eclipse in Turkey in 2006. You can see two there of the partial phase and one of the totality, and you can get an impression from the totality why it's that one. You've got to go and see if you can. The other picture I've included, not so clear, but when the crescent sun, partially eclipsed sun, shines through bushes and the like, or a colander, a kitchen colander is a useful one, all of the shadows come out in crescent shapes as well. Just something to look for. So, thank you for watching, and I hope that's been very informative. And all I ask is that you stay safe.